Okay, so the first important thing about this chapter is we need to be able to find the domain. Okay, so let's remind ourselves. Okay, so what does domain mean?
X values.
Yes, the x value. So we are checking for x values. But a fast way to check for x value is not to find the x value. Is to ask what can x not be in the function. So we're going to check what can x not, what numbers will x not work. So there are two parts that you need to check. The first one is the one we're going to check a lot. The denominator cannot be, cannot be 0. You cannot divide by 0 ever. So that is the first thing we're going to check. If there is a fraction, we need to make sure the denominator is not 0. So we're going to remember this. The egg goes on the plate. Whoops. It's not. And the plate cannot go on the egg. So if you have a...
Wait, so plate is...
The fraction bar.
Wait, what's the thing about the plate?
It is something... Okay, we don't need that thing. Okay.
Is that... Oh.
Let's just say it's like this. Okay. So you can have a 0. Okay, so you can have 0 divided by 2, but you can't have 2 divided by 0. Okay, very important. Cannot divide by 0, ever. So when we check, we are just asking ourselves, what can x not be? Because x can't be, the denominator can be 0. So for number 1, this whole thing cannot be 0. Whatever is in the denominator cannot be 0. So we just make the whole denominator not equal to 0. And then so x is not 0. So that's the domain. So domain means what can x be? We tell them it can be anything but 0. Because 0 is going to make the denominator 0. And that's not good. Okay? All right, second one. What can x not be?
3.
Yes, so this whole thing cannot be 0. So then if you just, solve, or eventually, you guys are already there, which is very fast, just make it not equal to 0 like that. All right, next one. Okay, what can x not be?
-6.
Good. All right, let's have you guys practice the next 3. Okay, number 1, there's only one denominator right here, so then x can't be 0. Number 2, x can't be 10, just like the previous ones. Number 3, there is no denominator, so then this is all real numbers. It's just a linear line, and that means everything works. So please be careful with not just making anything you see not equal to 0. The second thing, the radicand. The radicand, do you guys remember what radicand means? So like if you have a radical like this, the inside of the square root. Of a square root, only a square root or even root has to be positive, yes. So greater than or equal to 0. Has to be positive. Okay, so let's look at the question. So inside the square root has to be greater than or equal to 0. So we just make this part greater than equal to 0, and then we just solve. So then you're going to subtract 1 on both sides. So x is greater than or equal to -1. And that's it. So the domain is greater than or equal to -1. Okay, number 2 is a little bit trickier. You may not be able to do this in your head as well. So it has to be greater than or equal to 0, and then you solve. So the first few times you might want to just solve it, even though it might seem like, oh, I'm taking so much more extra time. It's actually going to make your answer more accurate. So you add the x over, so that means x is less than or equal to 3. That is the domain. All right, let's have you guys try 1 and 2. Again, there is a trick question somewhere in there. Okay, so this first one, this part has to be greater than or equal to 0, so you solve. It is x greater than or equal to 6. Number 2, this is a cube root, not a square root, so this is all real numbers. Okay, let's have you try all 9. 9 is an advanced question. It is tricky, so I think you guys are pretty good, so you can probably get it.
Too high of expectations.
No, I think you guys are pretty good. 1 through 9, let me know when you're done. Okay, number 1, 1, 2, 3, pretty much everybody's got, right? So x greater than or equal to 10. 2 is x is not equal to negative 10. Number 3 is x is not equal to negative 3. Number 4, it's all real numbers. There is no denominator or square roots. So that's that. Number 5, there is only one denominator, so not 1. Number 6 is x greater than or equal to negative 10. Number 7, whatever makes the denominator 0, there are 2 of them, so that means x can't equal to either one. Number 9, this will never be 0 because it's impossible. Unless you have imaginary, which are not real numbers. So it's all real numbers. Number 9 is a trick question. You have both a denominator and a square root problem. So first, you say this part has to be greater than or equal to 0. So that means x is greater than or equal to 6. But now it's in the denominator as well. So then it can't also equal to 6. So this would be the correct answer. No, because 6.5 works. Yeah, you forgot all the in-betweens. Okay, so we're going to start our section today. It's very easy. This is a review, huh? Yes, we're going to go straight to 8.4 because the beginning of the chapter is really hard. We're going to go to the back, which is the stuff you learned before. So very easy stuff. We're going backwards. We're going to do rational expression first. So rational, the word rational. Rational, we said at the beginning of the year, there is a special word inside the word rational. Ratio. Yes, ratio means what? Fraction. So we're basically doing all fractions this chapter. So something over something. Okay, so it's in the form of P of x over Q of x. So basically you have something that has an x over something that has an x, which is going to be the problem because there is a potential for the denominator to be 0. Okay, so we are going to just simplify rational fractions today, expressions today. First thing is factor, factor, factor. You always want to factor as much as possible. The second thing is know the restrictions on the variable. That means whatever makes the denominator 0. Before we cancel. The third thing is we're going to cancel out any factors that are the same, and we're done. So very easy. So for example, the first one. What is this in the simplest form? State any restrictions on the variable. All right, so the first thing is factor, factor, factor. So we're going to have to factor the numerator and the denominator. So what is the factored form of the numerator? 5 and 2. Yeah, x plus 5, x plus 2. What is the factored form of the denominator? Negative 5 and 2. Okay. Second step. Note the restrictions on the variable. So what can x not equal to? Okay, 5 and negative 2. Yes, both of them. So anything that's in the denominator is a problem. The last thing, cancel out any factors that are the same. Yes, and then the answer is x plus 5 over x minus 5. That's it. So very easy. Okay, so again, I believe you learned this before. This is just kind of a review. All right, so let's have you guys try this one. This one, there is nothing to factor. It's already factored. You have to check what makes the denominator 0. Okay, sometimes you have more than one variable, so then, what cannot be 0? And then simplify as much as you can. Okay, so the simplified form is negative 4x over y. What's the restriction on the variable?
They can't equal 0.
Okay, so x can't equal 0, y can't equal 0. So both of them can't be 0. Okay, let's have you try another one. Let me know when you're done. Okay, so first factor it, and you're going to get x plus 4, x minus 2. In the denominator, you're going to get a x minus 3, x minus 2. Okay, so before you start canceling, just write the restrictions. So that's 3 and 2. Cancel that, you get x plus 4, x minus 3. All right, next. We're now going to multiply two expressions together, but it's the same idea. Whatever is in the denominator is still a problem, and you still need to factor as much as you can. And this time you can cancel straight down or you can cancel across. So you want to cancel as much as possible. Do you need me to show you or are you okay?
Sure.
Okay. All right. So factor as much as you can. So that is going to be x plus 3, x minus 2 over x minus 5. The other one is x plus 5, x minus 5 over x plus 3, x plus 1. Again, before you do anything, write this restriction. X can't equal 5, negative 3, negative 1. So anything that's in the denominator. Next, you want to cancel as much as possible. You can cancel straight down or you can cancel across, because the whole idea is if you multiply it together, you're going to get across. That's all going to multiply together. So they're all in the numerator and then they're all in the denominator. So wait, I see this is the same. They're going to cancel. This is the same. They're going to cancel. So I have left with x minus 2, x plus 5 over x plus 1. Okay, easy. Let's have you guys try the next one. Let me know when you're done. All right, this one, the answer is 2 times x plus 1 over x plus 4 squared, because there are two of them. X is not equal to 4 or negative 4. Any questions on this? You okay? Okay. Next one, we're going to divide. And dividing is very, very simple. Remember, when you divide by a fraction, it's the same as multiply by reciprocal. So we're just going to do that. So the first one, we don't do anything to. And then the second one, we change it to a multiply, and then we flip the fraction. Okay, and the same thing as before, factor, 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 and then write the restriction. The only one that is a little bit tricky is this one. We don't usually see this. We always see x something, not a number and then x. So we're going to have to try to change that direction back. So let's kind of think about how to do that. So negative x plus 2, right? You're just switching the directions. But we don't see a negative on x. So yes, you would take out a negative 1. So basically factor out the negative. When you factor out the negative, another way to think about factoring it out is basically dividing each term by whatever you want to factor out. So negative 1. So it becomes negative times x what? Yeah, minus 2. So if you want to just rewrite that, that's a negative times x minus 2, and then you can do the rest. Okay, that way you will be able to see things that you can cancel that you wouldn't have if you didn't switch those two terms. Okay, let me know when you're done. Okay, so for this question, the answer is negative x minus 1 over x plus 1, x plus 5. X can't equal negative 1, negative 5, and 2. Okay, if you have not tried the next one, please give the next one a try. The answer is 2x over x minus 1. X is not equal to plus minus 1, 3, and negative 4. Okay, let's look at some that's a little bit weirder. Okay, this one. The problem is there is this negative 2 here. What do we do with that? Yes, anything that has a negative is telling you that factor is in the wrong place. So we're going to move it on top. Okay, so we have an x squared minus x squared, and then we move that to the top. Once we move it, the negative goes away. Over x times x squared plus 3x minus 4. All right, again, factor, factor, factor. This one is factorable, right? What can we do to factor that? X squared minus x. Take out the x. So that becomes x times x minus 1, the whole thing squared. Okay, all I did was I factored it from the inside. I didn't change the exponent, so the exponents apply to both of them. Okay, so then if I were to rewrite that, I would write x squared, x minus 1 squared, because it's basically distributed to both of them, both factors. And then we have another x1 minus 1 squared, and then you can factor the denominator. Okay, go ahead and finish this one. So eventually it becomes x times x minus 1 cubed over x plus 4, and x is not equal to 0, 1, or negative 4. Do you need me to go over it, or you guys are okay? You're okay? Okay. All right, number 2. So this is another way of writing a question. So you have a fraction over a fraction. What does a fraction over a fraction mean? What does this middle fraction bar mean? Divide. So it's just another way of saying ax squared y over x plus 1 divided by that fraction in the denominator. Okay, so it's the same kind of problem as before. So go ahead and do that. Write the restriction and write the simplified version. Okay, so the answer is 4x over 3y, and x can't equal negative 1 and 0, y can't equal 0. Okay, number 3, this is a tricky one. So again, do the same thing as before. So simplify as much as you can, and then I'm going to go over the restriction, because the restriction is a little tricky. So do number 3, and then we'll go over it. Okay, number 3, let's talk about this one. 9m plus 6n over m squared n squared. We're going to divide by 12m plus 8n over 5m squared. All right, so 9m plus 6n over m squared n squared times the reciprocal, so 5m squared over 12m plus 8n. Okay, we have to factor as much as we can before we cancel, so we're going to take 3 out. It's 3m plus 2n, and there's nothing to do in the denominator, times 5m squared over, take out 4, so 3m plus 2n. Okay, at this time you can see that they cancel diagonally, and the m's are going to cancel. But before that, we got to write the restriction. What's in the denominator that can't equal 0? So we have an m, right? So m can't equal 0. N can't equal 0. What else? Yeah, m and n can't equal 0. Anything that's a factor cannot equal 0. So that whole thing cannot equal 0. 3m plus 2n. Okay, what does that mean? That means if you happen to have a ratio of m and n that creates a 0 like that, then it's not going to work. Like, for example, if m were 2, n were negative 3, they would add together to get 0. That won't work. So whatever factor you have in the denominator, they all cannot equal 0. Okay, and then now you just simplify that, so that is 15 over 4n squared.